Good morning, students. This is videos for the week of February the 1st through the 5th. It is our beginning intro week to expressions. You have finished rational numbers, and now we're moving on. So these are the four things we're going to cover in this particular lesson today. I can determine if a quotient is positive or negative. That is a review from last time because that is more rational numbers, but we're going to just start off with this because we need to really understand this before we move on to the other things. The second I can statement is I can write exponents in expanded form. Exponents is something that you are supposed to talk about in 6th grade, but we will definitely refresh your memories on it in 7th grade, but you will be using these for here on out. I can evaluate numerical expressions. Numerical means all number expressions, okay? So we will be using order of operations for this. Most of you guys are familiar with PEMDAS, order of operations, but the term for those are called numerical expressions. And I can combine like terms to simplify algebraic expressions. So this is actually the very beginning of algebra. This is actually our next unit will be on equations. And so expressions is the beginning part of our algebraic section for 7th grade math. And so we will definitely be using some variables in these next couple weeks. So that's what we're going to do to get started. So now we're going to look at our first problems. And I will tell you, this may look familiar because as you see, I've written a video on this. I'm actually using your assignment. I believe this is assignment number 10, 9 or 10, I think it's 10, to answer some of these. So if you have assignment 10 and have not completed it, I hope you're watching the video first, then you will get some of the answers for assignment 10. And it hopefully will help you make it easier, okay? So let's start. It says, simplify the fraction using the rules of dividing negatives, okay? So we're going to go back to our rules. If we have an even number of negatives, well, if I can spell T-E-S, negatives, the answer is it going to be positive or negative? Even number means the answer is positive. 0, 2, 4, 6, whatever. If we have an odd number of negatives, the answer is negative, okay? So in other words, if we have 1 negative, 3 negatives, 5 negatives, or so on and so forth, the answer is negative, okay? All right, so in looking at this, our very first question is 10 over 15. So we're going to simplify the fraction and then also determine if it's positive or negative. So I'm going to first look and I see that I have 2 negatives out here. And if I go back to this, that there's an even amount and 2 is an even number, that means that this is going to be a positive answer. But I can also simplify 10 15ths by dividing them both by 5, because 5 is a factor of both 10 and 15. So when I do that, 10 divided by 5 is 2, and 15 divided by 5 is 3, and both of these negatives makes my answer positive. So my answer is simply positive 2/3. Okay, let's look at number 3. Number 3 is 4/8. And you may say, well, Miss Banks, what am I supposed to do with it, the negative when it's just out to the side and it doesn't look like it's attached to a 4 or the 8? all that means is that the whole thing is negative, okay? One of these 4 could be negative or the 8 could be negative. It doesn't matter because we know that if you have one positive and one negative, it makes the entire thing negative. So we just have one negative, and so our answer will also be negative. But before we do that, we're going to simplify this. So I can say that 4 and 8 both have a factor of 4. And so 4 divided by 4 is 1, and 8 divided by 4 is 2, and my answer will be negative. And it doesn't really matter if I put the negative out to the side or to the top or to the bottom, the whole answer is still negative. Okay? Let's look at number 4. Number 4 has got how many negatives? 1, 2, 3 negatives. So if we have an odd amount of negatives, our answer is also negative. So now we simplify 6/9. And we say 6, let's see, 3 is a factor of 6 and also a factor of 9. So 6 divided by 3 is 2, and 9 divided by 3 is 3, and our answer is negative. Okay. Let's come down here and do one that has a number that is actually bigger on top. Our numerator is bigger. So let's look at number 9. Number 9 is 18/4. So first, I see that there's only 2 negatives, so that's an even amount, then my answer is going to be positive. So I can go ahead and I can look at 18. What will go into 18? They'll also go into 4. Well, 4 won't go into 18, but 2 will. So I'm going to simplify my answer by 2. 18 divided by 2 is 9, and 4 divided by 2 is 2. And my answer is positive. Now, I could take that one step further if I choose to. Now, if you want to leave it 9/2, that's fine. But you can also turn it into a mixed number by saying how many 2's will come out of 9? Well, 4 2's will come out of 9 because 2 times 4 is 8. And that will leave 1 left. And so you keep your denominator, so 4.5. So you can choose to go all the way to the mixed number, or you can leave it as an improper fraction. That is up to you. Okay. I'm going to do one more. I'm going to look at number 8 over here because I have a parentheses and I have 2 negatives. And then I have another negative. And it doesn't really matter if it's inside the parentheses or outside the parentheses. They're always, you just count your negatives. So since there's an odd amount of negatives, my answer is going to be negative. So now I have to look at my 8 and my 48. And I know that 6 times 8 is 48. So I can simplify my answer by 8/8. 8 divided by 8 is 1, and 48 divided by 8 is 6. And I know this is negative, so I'm going to put a negative out to the side. And my answer is simply -1/6. Okay, so I've done 1, 2, 3, 4, 5 of these for you. You should be able to do the other 5 on your own. Now we're going to move to the next section. So we have covered, I can determine if a quotient, and a quotient is just the answer to a division question, is positive or negative. We've done that. If you have 1, 3, 5, 7, or 9 negatives, your answer is negative. If you have 0, 2, 4, 6, 8, 10, whatever negatives, your answer is positive. Now let's look at number 2. I can write exponents in expanded form. Okay, so number 11 through 20, we have numbers that have exponents. An exponent is the little tiny number at the top. It's smaller than the base number that it's serving, okay? What that means is that it does not mean 3 times 3. If I wanted it to be 3 times 3, I would just write 3 times 3. But this is 3 to the 3rd power. This is called a power, okay? And what that means is basically how many times am I multiplying that 3 times itself? So in order to write it in expanded form, I'm going to write 3, and I'm going to write that 3 times. So times 3 times 3. 3 times 3 times 3 is 3 to the 3rd power. Okay, and if I wanted to calculate that, It's not 18. Some people go, oh, there's 3 3s or 9. You would simply put in 3 in your calculator. You're going to type in 3 times 3 times 3. And that equals 27. Okay? 3 to the third power is 27, which makes sense because 3 times 3 is 9, and 9 times 3 equals 27. Or a shorter way to do this is to take your 3, that's your base number, and this right here, this little button right here is called the house top button, okay? It's your exponent button. So you hit the house top button, and basically it's saying the next number that I type is going to be the power of whatever number that I just wrote. So there is 3 to the power of 3, and that equals 27. It's the same answer. So you can multiply the number in itself by how many times, or you can just type 3, house top 3, and get the answer. Okay, but for this particular part of your work, I want you to write these out, okay? So this one is -6 3 times to the third power. So we're going to say -6 times -6 times -6, okay? So I have 3 negatives, which would mean my answer is going to be negative, and I have 6 to the third power. So 6, well, let's see, -6 house top to the third power is going to be -216, okay? So that is -216. Or we could just write -6 times -6 times -6. Takes a little bit longer, but you get the same answer. Okay. Number 15 is 2 to the fifth power. So what we will be doing is we're going to be writing the 2 out in expanded form, and we're going to say 2 times 2 times 2 times 2 times 2. That's 2 written out 5 times. Now, a lot of students will look at this and say, oh, that's 10. 2 times 5 is 10. That is not what that means. It means 2, we're multiplying 2 5 times. So we're saying 2 times 2, which is 4, and 2 times 2, which is another 4, right? 4 times 4 is 16, and then 16 times another 2, okay, which is 32. So let's see if I'm right. Let's do 2 house top, fifth power, 32. Or 2 times 2 times 2 times 2 times 2. I like doing the house top easier because it's a little bit faster, but it gets you the same thing if you write it out. Equals 32. Oops. 32. Almost wrote 36. Now this one is just 5 to the second power, so that's just 5 2 times. And it's 5 times 5. So 5 times 5 is equal to 25. Okay? We'll do the last one on this side, and you will be responsible for doing the ones to your right. So you'll have to write these in and these, but you'll have these already on a video. So the next one is -4 times -4 times -4. Okay? So -4 to the third power, -4, house top, third power, is equal to -64. Okay? -64. And that is how you write exponents in expanded form, and also how you solve for exponents. Okay, so let's look at our sheet again, our learning target sheet. So now we've covered I can write exponents in expanded form, and we could also write I can solve for exponents. So that would be another thing that we actually threw in there. The next thing we're going to talk about is I can evaluate order of operations, or I can evaluate numerical expressions. So right now we're just dealing with numbers and we're going to work with order of operations, okay? So how many of you guys remember, please excuse my dear Aunt Sally? I'm sure several of you do, from elementary school in 6th grade. The way we write this, we write P, then we write the E, and then I don't write the MD. I write those on the same line. I write MD and then AS. And the reason is because technically you multiply and divide in the order from left to right. There is no multiply first, then divide. If you have a question that has a division part before the multiplication, you take care of the division before you multiply. Same with adding and subtracting. You do that in the order from left to right. So I'm going to write left to right. Left to right. And we will talk a little bit more about this in just a minute. Now let's talk about the parentheses. Parentheses also mean any groups. I will tell you, in other countries, PEMDAS is actually called GEMDAS, GEMDAS, because the G stands for grouping. We call it parentheses, but it's any kind of groups. It's brackets, it's parentheses, it's any kind of groups that you have in math. So the parentheses, always just remember that it's actually a grouping thing. It's not just about parentheses, okay? And then our E is our exponents, right? And that is just what we talked about. So we have to take care of any squareds or thirds or to the 4th power or anything else that we do before we do any multiply and divide or add and subtract, okay? So this is the order. There is also, we can call it GEMS, G-E-M-S, groups, exponents, multiply, divide, add, subtract. That's another acronym for PEMDAS. So however you want to remember it, or however it's been taught to you, this is what we have to do when we are evaluating any kind of algebraic or numerical expressions. All right, so let's start with the numerical, okay? So I'm going to actually start with, still on your paper, you have a couple on the bottom page of the first one, but I'm just going to start with the ones on the back. All right, so I'm looking at question 23, and I have in parentheses 4 minus -2, parentheses close, squared. Okay, so PEMDAS tells me, or GEMDAS, whatever I want to call it, tells me I have to deal with the parentheses first. Okay, but inside the parentheses, I have what we know as a double negative, or add the opposite, which goes back to what we learned in our last 2 units on rational numbers. When we have a 4 minus -2, we have to add the opposite. So that doesn't go away, guys. Just because we go to another unit, that doesn't mean the rules for adding and subtracting or multiplying, dividing are no longer useful. Everything you learned, we built on it. So now this is not 4 minus -2. This is actually 4 plus 2. Now, if you want to put it in the calculator like this, 4 minus, you have to use the negative in the calculator instead of the minus sign, or it gives you an error. -2, and I get 6. 4 take away a -2. Or 4 plus 2, which is 6. So either way we go, we know that this is 6, right? And then it's squared. So now we just have to figure out what 6 squared is. So 6 house top. Actually, instead of using the house top, if it's a squared, we can just use this one because that's any number to the 2nd power. So if it's anything past the 2nd power, you use the house top. But if it's just squared, we can just do this and put 6 squared. See how neat that is? Okay, so 6 squared is 36. So the answer to this question is 36. Okay. Now let's look at number 25. We don't have parentheses, but we do have an exponent. So we have 3 squared. 3 squared is 9. And 9 minus 1 is equal to 8. Okay. Let's do the next one. We have negative 2 times 3 times negative 1. Okay. So all of this is multiplication. So we don't really have to figure out what we need to do first or second. We're just going to multiply negative 2 times positive 3, and we get negative 6. And then negative 6 times negative 1 gives us a positive 6. Easy enough. Okay, let's skip down to 31 here. 31 looks a little complicated. We have a negative 4 inside the parentheses. And so we're going to square that negative 4. So we take negative 4, and we're going to square it. And we get, which actually that's supposed to be 16. So we have 16, okay? Because we're squaring the negative. That's negative 4 times negative 4. So negative 4 times negative 4 equals 16. All right. So minus 6 minus negative 6. And now I'm looking at, I have all subtraction. So I've taken care of the square first. My parentheses, my square. Now I've got to figure out, this is going to be add the opposite. So I make that negative 16 minus 6 plus 6. So if I put that in the calculator, or 16, I said negative, sorry. 16 minus 6 plus 6, which it just means that you're taking away 6 and adding it back, you should get 16. Okay? All right, look at number 33. Number 33 has got 2 sets of parentheses. Anytime you have 2 sets of parentheses, you always work from the inside out. Okay? So you start with the inside, and then you work your way out. So the inside parentheses is negative 2 minus 3, and if you add the opposite, that's negative 2 plus negative 3, which is negative 5. Or you put it on your calculator, negative 2 plus negative 3, or negative 2 minus 3 gives you negative 5. And then in that, you have negative 5 times 2. And then you still have the divided by negative 2 out on the outside. So then we're going to take care of the negative 5 times 2, which is negative 10. Now we have negative 10 divided by negative 2. And so I have 2 negatives, which make a positive. So 10 divided by 2 is just going to be positive 5. Okay. Let's skip down here and look at some of these really long ones. Let's look at number 41. 41 has 5 minus 6, parentheses open, 6 minus 5, parentheses closed, plus 5 squared. So we have to start with the parentheses. So let's start with this step first. We have 6 minus 5 is 1, right? So now we're take the 5, bring the minus sign down and the 5 down, bring everything down, bring the plus sign and the 5 squared. Now the next thing we must take care of is the 5 squared. So I'm going to say 5 squared is 25. Bring everything else down. Now we just add and subtract from left to right. So 5 minus 1 is 4, and 4 plus 25 is equal to 29. Let's test that. 5 minus 1 plus 25 is equal to 29. Okay. All right, so let's look at one more. Let's look at number 42. 42 is pretty crazy looking. 42 has a parentheses, a division sign, and another set of parentheses. So what we're going to do is we are going to go ahead and solve what's inside the first set of parentheses first. So we just have subtraction and addition. So we say 2 minus 1 is 1, and 1 plus 11 is 12. So that is 12. And then divided by, and then what is 2 plus 4 is 6. So all of this just simplifies down to 12 divided by 6, which we know equals 2. Okay. All right. Let's do two more. We're going to do these two, 44 and 46, and then we'll move on to the next thing. 44 is, we're going to start with what's inside the parentheses. So we are going to look at this. Now, if I had a multiplication sign inside these parentheses, I would have to do the rules inside the parentheses. So in other words, if this was 5 minus 4 times 5, I would have to multiply the 4 times 5 first and then do the 5 minus 4. Okay, so even if you're inside the parentheses, you still have to keep the same order of operations. Do not think that you just, like, the rules still apply even in this little tiny section as versus the whole thing. So we're going to say 5 minus 4 is 1, and 1 plus 5 is 6, okay? That's what's inside the parentheses. Now we're going to bring the 3 down. It's outside the parentheses, minus 2. Now, this is multiply, because if you have a number beside the parentheses, that means multiplication, okay? So we're going to say 3 times 6 is 18, and 18 minus 2 equals 16. Okay, now one more, and this is right here. We have a set of parentheses with an exponent on the outside. So we're going to start with doing the parentheses first, or what's in the parentheses first. 4 divided by 2 is 2. And then I'm just going to write everything else down just because it makes my life easier to just write step by step. And then I say, well, we got to do the squared. So 2 times 2 squared is 4. Matter of fact, that is the only one that if you say 2 times 2 and 2 squared is the same answer, because most things don't work that way. Most of your squares are bigger than what you multiply by. Bring down your times 2 minus 4. Now, then we're going to say 2 times 4 is 8, right? And 8 minus 4 is equal to 4. So all of that simplifies down to 4. You can solve it for 4. Okay. Number 50, you do what's inside this parentheses, you do what's in this parentheses, and then you multiply them together. Okay. This is 3 squared is 9 minus 4. 3 plus 1. So 9 minus 4 is 5. And 3 plus 1 is 4. And then you just multiply them. 20. Okay, so now we can check off this. We can say that we have evaluated numerical expressions. So far we have determined if quotient is positive or negative, written exponents in expanded form, and evaluated order of operations or numerical expressions. So the last thing we're going to do is I can combine like terms to simplify algebraic expressions. So like terms is going to be a very big vocabulary word for us, okay? Like terms means that they have the same endings. So we're going to look at this page here. Now, this is not a page that you have to do. I created this assignment just for the video, but you will have, I think, assignment 12. You start like terms. It's just on a different paper. Okay. So like term is, let's go to kind of a study here. If you look at the numbers 6 plus 9 minus 2, we've already looked at these. These are all numbers. Okay, so technically these are all considered like terms. Now, nobody's ever told you that before. Nobody's ever said that 6 and 9 and 2 were ever considered like terms. But when you start talking about algebra, these are called constants because the number never changes. This will always be number 6, this is always number 9, and this is always 2. Okay? But if we were to say 6a, now we're saying 6 times a number, a variable, that we could replace anything for a. 6a plus 9b minus 2a. Now, this is different. They have different terms. Like I said, these are called constants because they don't change. With this, all of these are called terms. Okay? On your last assignment for this week, you're going to see a term dissected. Okay? And that term, I believe, let's say it's 6a plus 2. It's going to tell you that this is called a term. Okay? This is also called a term, but it's a constant. So we're going to put this as a constant. This right here is the operation. This is your add, subtract, multiply, or divide, right? This number, this little letter here is called a variable. And the 6 in front of the variable is actually called a coefficient. Okay? These are all of the things that you need to understand when you're talking about algebraic expressions. Both of these are considered terms, but this is an algebraic term that has a coefficient and a variable together. You multiply them together. And this is just a constant because it doesn't have anything that you multiply with it or divide with it. And the operation in between is just your add, subtract, or multiply or divide. Okay? So when we're looking at this, we have 6a plus 9b minus 2a. They're no longer like terms. They're not all numbers anymore. We have variables. So we have a coefficient and a variable, an operation. A coefficient, a variable, an operation, a coefficient, a variable. But what we have to do is we have to determine if there's any like terms inside of our expression. Well, I see an a here, and I see an a here. So these two are both like terms because they have the same variable attached. It doesn't matter about their coefficient. They have the same variable. So what we're going to do is we literally, and we have to take the sign in front of it, so that's a minus 2, and there's no sign in front of this, so that's just a 6a, and we're going to pull these down, and we are going to combine them. And when I say combine them, I'm going to say 6a minus, because that's a minus 2, minus 2a. 6a minus 2a is just 4a. 6 minus 2 is 4. The a's don't change because it's like their last name. That is 4a. Okay. 9b, it doesn't have a partner. It's just 9b. So we don't have anything to combine for that. So we just have 9b. So what we're going to do is we're going to use the 4a, and we're going to say 4a. And then I see here that 9b has got a plus sign in front of it, right? It has plus 9b. So I'm going to bring that plus 9b down. And that is my simplified term. Can I solve this? Can I make it just one number? No, I can't. Not without knowing what the A and the B stands for. I cannot do anything else with this. So this is a simplified expression. And that will be the answer that we're looking for. Okay, so I go to number 1 on this paper. I'm going to actually circle my M because I have a negative, and that's like -1M. And then I look and I say, well, I have a +4 and a -9, so I don't have anything to match the M. So I'm just going to write -M down, -M. But my 4 plus 9, or 4 plus -9, 4 minus 9, right? 4 minus 9 is equal to -5. So I just bring -5 down. And that -M minus 5 is my combined term. Number 2, look at here. I have -2n plus 3n. So I only have the one term. I don't have 2 separate types of terms. So I look at that and I go, well, I have an n here and an n here, so I just combine them. So -2 plus 3 is just 1. So I can write 1n, or I could just write n. Okay, let's look at the next one. I have a -5. Then I have, this has got an x on it, and that has an x on it. So I have 5x, and I have a plus 2x. So plus 5x plus 2x. This one doesn't have any partner to combine. So let's look at 5x plus 2x. 5x plus 2x is just, and they're both positive, so it's just 7x. So I'm going to bring down my -5, and since this is plus 7x, plus 7x. And that is my combined term. Now, let's look at a couple more. Let's look at, pause.
You doing all right today?
Okay, let's look at number 7. Number 7 is, I have a P, and then I have another P here, so that's -7P, and this is just P. Okay, so I have those two terms, and then I have a -3, and I have a -8. So I have P minus 7P, and if you have a variable or a variable that doesn't have a number in front of it, just know that's a 1. 1P minus 7P. So 1 minus 7 is equal to -6P. And then I have -3, and then -8. And if you want to put that in the calculator, -3 minus 8, now we're still back with our rules here. -3 minus 8 is -11. So our actual combined term is going to be -6P minus 11, because that's a negative sign, so minus 11. So that is our combined term. Okay. Now, if you have to do fractions or decimals, don't let them freak you out. It's the same thing. So I would look at this one and I would say, okay, let's look at this one here. 2V and -1/2 V. Okay. And then I have a positive 2/3 V that doesn't have a partner. So let's start with the 2V minus 1/2 V. So 2V minus 1/2 V. Just type in your calculator 2 minus 1/2. 2 minus 1/2 is 1.5, right? So 1 and 1/2 V. So you just type it in without the variable, and then make sure you put the variable back in. And then this guy doesn't have a partner, So our answer is just going to be 1.5 V plus, because there's a plus sign in front of him, plus 2/3. And that is your answer. We'll do one more with decimals, and then I'll let you guys get to it. So let's do number 17. Number 17, we have, looks like we have 0 tenths. That's got to be, and then we have positive 4 tenths. Okay, and then I'll look back and I say negative 6.9 V and negative 6.9 V. All right, so let's start. Negative 6.9 V minus, because that's a minus sign or negative sign, 6.9 V. So I'm going to just type that in. Negative 6.9, don't have to worry about the V's, minus 6.9, and I get negative 13.8. So I know this is negative 13.8 V. Don't forget my V. Now let's do my 0, 2 tenths. That's positive, and then plus, because that's the plus sign in front of it's positive, plus 0.4 tenths. So 2 tenths plus 4 tenths, which is 6 tenths, but I'll show you. 0.2 plus 0.4 is 0.6 tenths. So that is 6 tenths. Now, put them together. We're going to say negative 13.8 V plus 0.6. And that is our answer. Remember, you cannot solve these. You are only simplifying these because they have different variables. And unless you know what the variable represents, you can't go any further. It's not like a numerical expression that you can solve it down to one thing. The numerical expressions, you can get them to be one answer because these are all considered like terms. All of your constants are considered like terms. These, however, have variables, coefficients, and constants, and you cannot combine them with adding and subtracting. So make sure that you understand that these will not go into one simple answer. They have to just be simplified as an expression. Okay? That is everything for this week. You guys have the basics down for what you're going to need. I hope that you understood this video and enjoyed it, so you guys can do all 4 of your learning targets for this week. You guys have a great week, and I will see you later.